Myself, Prabha Ranjay, working as an assistant professor in EC department at SNS College of Technology. In this lecture video, I am going to discuss about the topic name is Decimation in Time algorithm in Fast Fourier Transform from Unit 1, which is discrete Fourier Transform. In subject is digital signal processing. Yeah, let us discuss. First of all, why we are using fast Fourier transform means both discrete Fourier transform and fast Fourier transform is used to convert time domain sequence to frequency domain sequence. Mm, when we are using DFT, the processing delay will occur because DFT has large number of computation level, which means more number of iteration level. It leads to processing delay. To overcome this processing delay, we are going to use fast Fourier transform. In fast Fourier transform, large number of samples going to decimate into small number of subsequence. Because of this processing delay, when we are using DFT, processing delay will occur. Because of this processing delay, we cannot able to apply the more number of applications. Also, filtering of the signal is also a slow process. So to overcome this all problem, we are going to use fast Fourier transform. This FFT has two algorithm, which means first one is decimation in time algorithm and second one is decimation in frequency algorithm. In this lecture video, I am going to explain decimation in time algorithm. This is the basic flow graph for the decimation in time algorithm in FFT, which is called as radix 2 DIT-FFT algorithm. You can see two horizontal line, in between one cross is there. Left side of this flow graph is input of the input, and right side of the flow graph is output, and input which is nothing but the A and B, and twiddle factor is W suffix N and prefix R. Twiddle factor which is used to combine the two input. Twiddle factor is represented as W suffix capital N prefix small r. Capital N is nothing but the length of the sequence, and small r is nothing but the index of the sequence. And output for the upper part is represented by capital A. Lower part, output of the lower part is represented as a capital B, and formula for the upper part is A, small a, which is first input plus second input multiple with twiddle factor. Same thing, formula for the lower output is so first input minus second input multiple with twiddle factor. First input is nothing but the small a, and second input is nothing but the small b, and twiddle factor is represented by W suffix N prefix R. And here you can see this is the flow graph for the 4-point DIT-FFT. This is the flow graph for the 4-point DFT-FFT. Here capital N equal, this is the formula for radix 2. Capital N equal to 2 power P. Capital N is nothing but the number of samples, and 2 power PP is nothing but the number of stages to calculated. Uh, capital N equal to 4, and which is equal to 2 power 2. Number of stages is 2, stage 1, stage 2. And first of all, you have to take bit reversal order for the index of the input sequence. Then you have to map in the flow graph. Input in the sense it is the left side of this flow diagram, and output is right side of the flow diagram. X of 0, X of 2, X of of 1, x of 3. This is the input, bit reversal order input, and output is x of 0, capital X of 0, x of 1, x of 2, x of 3. Input, input is nothing but the time domain, output is nothing but the frequency domain. And one more thing, first stage, twiddle factor for the first stage is nothing but the W4 of 0, and twiddle factor for the second stage is W4 of 0 and W4 of 1. This is the how to calculate bit reversal order. Okay. Original format is 0, 0, 1, 2, 3, which means x of 0, x of 1, x of 2, x of 3. Index is 0, 1, 2, 3. Its binary format is 0, 0, 0, 1, 1, 0, 1, 1. Then its bit reversed form is 0, 0, 1, 0, 0, 1, 1, 1. This is the decimal value of this concerned binary format is 0, 2, 1, 3. This order you have to map in the input side. This is the flow diagram for the 8-point decimation in time algorithm. N equal to, n equal to 2 power p. N is nothing but the length of the sample, which is equal to 8. 8 equal to 2 power 3. Number of stages is 3. Okay. Here you have to map bit reversed input order. Then you have to calculate output for the first stage. Then this output going to consider as a input of this second stage, and calculate output of this second stage, and this output going to consider as the input of the third stage. Finally, going to consider as the input of this third stage. Finally, we have to take output for the total 8-point sequence. This is the bit reversed form. How to calculate bit reversed form means we have to write the index 0, 1, 2, 3, 7. After that, have to binary format of this concern index value. Then because why we are going to take a 3-bit means total 8 equal to 2 power 3. 3 bit we are going to use 3 bit. So this is the reverse form. This is the that decimal value for that binary values. And first you have to calculate 2-point, then calculate 4-point sequence, then you have to calculate 8-point sequence. First output of the 2-point sequence is going to consider as a input of the 4-point. Then output of the 4-point is going to consider as a input of the 8-point, and final output is output of this 8-point sequence. This is the assessment question of this lecture. First question is, what is meant by FFT, and list the methods of FFT. Second question is, in fast Fourier transform, from which domain can be converted into which domain. In decimation in time algorithm, the flow graph is represented as dash point, comma 4-point, comma dash point FFT. And fourth question is, what is difference between the direct computation and radix 2 FFT. And fifth one is you have to convert time domain to frequency domain. Time domain sequence is the x of n equal to 1, 2, 3, 4. And sixth question is, in fast Fourier transform, number of complex multiplication, how many number of complex multiplication, and then how many number of complex addition. If you have any doubt, you can ask me through the comment. We will meet in next video. Thank you.